and 12.
10 and 12. Base and base. Okay? Now we're going ABC to BCD. So ABC is 10. BCD's, its corresponding base was 12. What am I working towards right now? My scale factor, but I have to do what to this?
Reduce.
I need to reduce this. Both of them can be reduced by 2. All right, so if my scale factor is 5 to 6, then the ratio of the areas is what?
25
to 36.
25 to 36. Very good. What would be the ratio of the perimeters? 5 to 6. All right, for homework, you're going to have a chart similar to this one, where you're trying to show the relationships between scale factor, perimeter ratios, and area ratios. Well, scale factor and perimeter ratios are what?
the same.
They're exactly the same. So we can fill in over half this chart right now by simply copying down information. But now, how do you get the ratio of the areas? You've got to, no, right here. I'm looking at this first column. If I want the ratio of the areas, what do I do with these two numbers? I square them. So I have 1 to 9. I square these. So I have 1 to 25. What's the next one?
9 to 16.
9 to 16. What's the next one? 16 to 25. Be careful you're not doubling, but you're actually squaring. Okay? All right? In the last two columns, we're given the area ratios. So how do we work backwards? You take the square root of 16 and 49. 4 and 7. Which the scale factor is exactly the same. And for 36 and 25, it would be?
6 and 5.
And the scale factor is exactly the same. Okay, so you have a chart tonight that you need to fill in, and it's pretty easy. And then you're going to have problems where you need to apply further. Yes. Yes. Okay. All right. I am giving you the radii of two circles. And first thing we need to know is this. Are all circles similar?
Yeah.
No.
All circles are similar. Think of the shape of a circle. Is it the same as the shape of a circle? Yes. Just like all squares are similar. Just like all rectangles are similar. Wow. Okay. Anyway. If the radius of one circle is 9 and the radius of the second circle is 12, what would the scale factor be? 3 to 4. Remember, scale factor is expressed in lowest terms. And 9 and 12 can both be reduced by 3. Which means the ratio of the circumference would be what? Why?
Because it's the same thing as the perimeter.
Because circumference is the same thing as perimeter. All right, and anytime you're just like going straight, you're not covering area. Area, think of wrapping a box. Okay, you got to get paper to wrap the whole box together. If it's not covering the whole area, then it's just the same as the scale factor. But the ratio of the areas would be 9 to 16. Okie doke?
Is that homework this easy?
No. Alright, draw this picture real quick. You have a small triangle sitting at the top of a larger triangle. The two bottom lines are parallel to each other. And it's region 1 and region 2. And I'm going to ask you a trick question. Is region 1 similar to region 2?
No.
Oh, good. The other classes said yes, then they stopped and thought about it for a second. Why not?
Because
It's not a
two
triangle.
is just that little piece of.
Give me 5. Don't leave me hanging.
Oh,
Right, because region 1 is a triangle while region 2 is a trapezoid. What is region 1 similar to?
the whole triangle.
The whole triangle. 1 and 2 put together. Okay, and this is why it's important. If we're going to find the scale factor of the two similar triangles, is it going to be 2 to 3 or 2 to 5? 2 to 5. The scale factor is 2 to 5. And that's because we must take the side of one triangle, which in this case would be AE, and compare it to the corresponding side of its similar triangle, which would be the whole thing, 2 and 3 put together. All right, so if that's the case, tell me the ratio of the perimeters. Tell me the ratio of the heights of these triangles. Tell me the ratio of the areas of these triangles. Very good.
But why is the height the same?
They're not the same. The ratios of the heights, because it's going to be the heights drawn from the same corresponding bases. Okay, the reason that last one, and I didn't point it out, and I want to point it out now. Okay, you see how we said the heights were the same here? All right, but those are heights drawn from two different bases. Okay?
Okay.
So we couldn't say that these two heights are specifically equal to each other. The actual heights, if they are the corresponding heights drawn from the corresponding bases, will have the same scale factor. So if 10 I don't know. I've confused myself. But anyway, what I said. Okay. Let's go. All right. If there are some pies in these areas, what do you think we're talking about?
Circle?
Circles. Okay, we've got two circles. One of them has an area of 36 pi, and the other one has an area of 64 pi. And we are going to try to find the ratios of their diameters and the ratios of their circumferences. Which, by the way, will be the same thing. Which, by the way, will be the same thing as their scale factor. So, what I've got to do is start with their area ratios and figure out what the scale factor is by taking the square root. But remember that ratios are expressed in
Lowest term.
lowest terms. So if I simply stick 36 pi next to 64 pi, is that lowest terms?
No.
No.
What can 36 and 64 both be divided by?
2.
4. 36 and 64 can both be divided by 4. And they also can both be divided by what? Pi. So if I reduce these both by 4 pi, I get a scale factor. Oh, excuse me. It's not my scale factor yet. I get a ratio of the areas that is 9 to 16.